6.4 is going to be over logarithms. So let's define what a logarithm is. We're going to call it logs for short. They're just inverses, or an inverse, of exponentials. So here's an exponential form of something. If I convert this directly to log form, we're going to say log base a of y equals x with the same a, x, and y. So in an exponential, you can see over here, the unknown x is in the exponent. A log solves for the exponent, thus solving for the unknown. So we can use logs to solve exponential equations. Let's get familiar with this conversion. Let's take some exponential forms that we know and convert them to log form. Here's an exponential. We convert it to log. It's log base 2 of 8 equals the exponent 3. Here's another one. 5 squared equals 25. That's log base 5 of 25 equals 2. If we convert something from log form to exponential form, that's going to be log base, it's exponential form, so it's going to be 3 to the 4th equals 81. Or, let's do this one. That's going to be 6 to the 3rd equals 216. Now, let's look over here at the graph. Okay, so let's look at f of x equals log base 2 of x and kind of see what the graph looks like. Now, last time I mentioned the graph of exponentials. I didn't show it, but let's look at it right now. This is what an exponential looks like. This is 2 to the x. As we come down here from 0 down into the negatives, when we start putting negative numbers in, it starts getting extremely small. For example, like let's say over here we have 2 to the x. 2 to the negative 2 is 1 over 2 squared, or 1 over 4. That's a fraction. If I go 2 to the negative 3, it's going to be 1 over 8, a smaller fraction. So as we get smaller and smaller and smaller with are more and more negative with those numbers, these fractions are going to get smaller and smaller and smaller. So this guy never goes to 0. Now what is this? Let's go back up here. Look right here. Y, okay, as I put in negative x, we get out y. And we said that y in this exponential never gets to 0 and it never goes negative. Okay, y is never 0 or negative. So then going over here, this y can never be 0 or negative. So we cannot take log of 0 or negatives. So, let's say I want to find the domain of a log function. So let's say I have f of x equals log base 2 of x plus 3. This x plus 3 in parentheses can never be, well, sorry, I never looked at the log. I forgot to actually graph a log. Sorry about that. Okay, so that shows that log never becomes negative or go to 0. So again, this guy in parentheses, x plus 3, can never be negative or 0. So we need that guy to be always greater than 0. And if I solve that, x always has to be greater than negative 3. So whenever we describe our domain, it is from negative 3 to infinity. That's it. Another example. So we have log base 5 of x plus 1 over x minus 1. So right away you can see that the bottom part cannot equal 0 because we learned that in just whenever we first started talking about functions, that the bottom part cannot equal 0. So right away we see that x cannot equal 1, positive 1. Now we also know that that quantity, what we're taking the log of, always has to be greater than 0. Now if I multiply both sides by x minus 1 to get rid of that fraction, over here on the right hand side it's still 0. So that's all we have to solve right there. So x always has to be greater than negative 1. So we have two constraints on our domain. So the domain of this guy is going to always be greater than negative 1, and it messes up at 1 and goes to infinity. Okay, now let's look at some special forms, special logs. Okay, so log is always going to be like log base a of y equals some x, where a can change. But if you look on the calculator, we have a button that says log. So if I just click it, it doesn't let me change the base. Okay? So we're going to talk next time a little bit more about how to use the calculator to evaluate logs. But there is only two logs built into the calculator. Log base e, which we talked about e being a number last time, we have a special notation for it. It's ln, and that stands for natural log. And then log base 10, we just write as log of x. If there's no base on it, that's an implied base 10, and that's what's in the calculator. So when I do that, that says base 10. Okay? These are the only two in the calculator. Now, we will show next time how to evaluate those in the calculator, even if you don't have a way to change it. Now, the old calculators, the 83s, you cannot change it. But if you have one that looks like this one here, if you hit alpha F2, right here, the fifth option, it gives you the option to change the base. Now, that's a new option. Some of the old calculators don't have that. Most everybody has the new ones, not the old ones, so it should be okay. But if you have one of the old ones, I'll show you how you can still evaluate those just using these two guys, the ln and log. Okay, log base 10 and log base e, natural log. Okay, so let's look at just a couple examples of how you would solve logs and exponentials using the calculator or just by hand. So let's say we have this log. If I want to solve this, I can't right now. But if I put it in exponential form, it'd be 3 squared equals 4x minus 7. And you can solve this. 3 squared is 9. Then you get 4x minus 7. Add 7 to both sides. Divide by 4. X equals 4. There's another example. Log base x of 64 equals 2. If you convert this to exponential form, you get x squared equals 64, and we know how to solve that. Square root both sides, and square root of 64 is plus or minus 8. Now, what about something in exponential form? If something's in exponential form, it can help to switch it to log form. So this is e to the x equals 5. That's base e. If I change it to log form, that's natural log of 5 equals x. And I have solved it. X equals the natural log of 5. Now, if we want to approximate it, we can go to the calculator and do the natural log of 5. Now, you can see it gives me a decimal, so anytime I round my decimal, I'm approximating, so I put the little squigglies. So let's just say we do 3 decimal places. 1.609. Here's another one. 10 to the 2x equals 6. Okay, we can only do these two because they're base 10 and base e. That's within the calculator. But next time, if it's something different, I'll show you how to do that as well. Okay, so if we convert this to log form, that's log base 10 of 6 equals 2x, which we know is just log of 6 equals 2x. Then divide by 2. So x is log 6 divided by 2, which is approximately 0.389. Okay, so there's a little introduction to logs, so we'll stop there.